Okay, welcome back. This is our second snow day video on simplifying radical expressions. Now, I wasn't thinking, but my assumption was that all of you have your books at home, but that may not actually be the case. So in case you left your book at school, I have put the 5 homework questions from the previous video on the board here so that you can see them. This is the homework off of page 434 of the textbook, but I've just gone ahead and written the problems out. So you have 5 questions. This one that's circled at the bottom, the 5th question here, just checking this to let you know there is absolute value in this question. Now, if you didn't quite understand the whole concept of even divided by even gives odd, I'm not really necessarily worried about that right now. I just wanted you guys to see that we are going to be dealing with some sort of absolute value case with respect to radical expressions. But if you did understand it, then I want you to write the answer correctly to this problem. Now, for today's lesson, I have 3 homework problems on the board given here. Okay, now, we're looking today at what happens when exponents do not divide evenly, or they don't divide without a remainder. Let's look. Here they do. This is like last night's homework. So we just take our exponent 6 and divide by what? We're dividing all the exponents by 3. So we get x to the what? 6 divided by 3, y to the 9 divided by 3, and then just simply divide. 6 divided by 3 gives 2, so we get x squared, and 9 divided by 3 gives 3, so we get y to the 3rd, and we do not have to worry about absolute value because the index is odd. Now, I have to keep using this word index. I just want to show you really quickly. When writing a radical expression, we have this symbol is a radical symbol. Underneath is called the radicand. Okay, so I will use these terms, radicand, and up here this little number is called the index. Okay, so the number here, the 3 is the index, and the x to the 6th, y to the 9th is called the radicand. So I will be using these terms as we go. Now the question is there another way to do this? We know divide by 3, we get x squared, y cubed. Okay, so I'm going to erase the homework off the board. Now, dividing is the same as circling groups. And I'm going to show you. If I say, what is 12 divided by 3? What is 12 divided by 3? Well, you would all say 12 divided by 3 is 4. Look, I'm going to put 12 lines on the board. 12 divided by 3. Dividing by 3, 12 divided by 3, is the same as circling groups of 3. So I've put 12 lines. Circle groups of 3. Circle groups of 3. Circle groups of 3. Circle groups of 3. So dividing by 3 is the same as circling groups of 3. How many groups do we have? We have 4 groups. So the answer is what? The answer is 4, or the number of groups. So this is the number of groups. The answer is the number of groups. Okay, so dividing by 3 is the same as circling groups of 3. Let me show you here. So we're going to write this as the cubed root, and I want you to write these out tonight. Okay, or at least the first problem I want you to write it out and see it visually. So we have 6 x's. 1, 2, 3, 4, 5, 6 x's multiplied together. We have 9 y's. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 6 x's, 9 y's. Since we're dividing by 3, this is the same as circling groups of 3. So we're going to circle a group of 3 x's, circle another group of 3 x's. Okay? And now circle groups of 3 y's. So circle a group of 3 y's, circle a group of 3 y's, and circle a group of 3 y's. Now the question is, how many groups did you have? Well, how many groups of x's? Every x comes out from underneath the radicand, and every group of x's becomes 1 x on the outside. So this group of 3 x's comes out, becomes an x. This group of 3 x's comes out and becomes what? An x. And we multiply these together. X times x gives an answer of x squared. Now, every group of 3 y's also comes out. Every group of 3 y's comes out, and each group gives a single y on the outside. Since we have 3 groups coming out, we have 3 y's. I'm just going to put them here. A y, and a y. Each y represents one group. So this group of y's gave what? This group of y's gave a y. This group of y's gave a y. And this group of y's gave a y. So we have 3 y's coming out because we have 3 groups. So y times y gives what? Y to the 3rd, and we get the same answer. X squared y to the 3rd. So the concept of dividing by 3 is the same thing as circling groups of 3 underneath the radical. Okay, so let's look again here. Let's look at what happens. So you have to use this technique when things don't divide evenly. Let me show you. Okay, so 3 examples and then we're done. So quickly, looking at this first, this is the 4th root of, let me write that could see fourth root of 48, a to the 24th, b to the 13th. And let me make this a to the 12th. That will be more reasonable. Now, what we're going to do is we're going to take the 48 and break it down. Always take your number and factor it down immediately. Remember, we're dividing by the numbers, either dividing by 2, 3, 5, or 7. Every once in a while you're dividing by 11, but not often. Okay, so 2, 3, 5, or 7 are most common. So we start with 2. If it's divisible by 2, if the number's even, it's divisible by 2. So 48 is even. We can divide by 2. 48 divided by 2 gives what? 24. Divide by 2 again. 24 is even. Divided by 2 gives 12. And now divide 12 by 2. 2 times what? 2 times 6. Divide the 6 by 2, which is 2 times 3. And we can look. Okay, so what do we have here? 48 is 1, 2, 3, 4 2s. 2 times 2 times 2 times 2. And a 3. Okay, so 4 2s and a 3. We can rewrite this as the fourth root of what? The fourth root of 2 to the 4th. 2 to the 4th times 3 times a to the 12th times b to the 13th. Now we're going to write this out. So I told you for the first problem tonight, I want you to write this out. So we have the fourth root of how many 2's? Well, 1, 2, 3, 4 2's, because it's 2 to the 4th power. We have 1 3 and 12 a's. Okay, so 12 a's. This takes a moment. Here. I can fit it. A times A times A, A times A times A, and 13 B's. So 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't worry, you're not going to have to do this every problem, but I just want you to visually see what's going on here. So notice, dividing by 4 means circling groups of what? Dividing by 4 means circling groups of 4. Can we circle a group of 4 2's? Yes, so I want you to circle this group of 4 2's. Now remember, every group comes out and becomes how many on the outside? Every group comes out and becomes 1 on the outside. So let's go ahead and put, since we have 4 2's, this group of 4 2's is going to come out. We're writing our answer. This is the answer. Okay, so the answer is how many 2's? Well, we have 4 2's. 4 2's. One group. One group comes out, becomes 1 2 on the outside. So every group becomes 1 on the outside. We have a single 2 on the outside. Now, circle groups of 4A. Or I should say this. Can we circle a group of 4 3's? No, there's only 1 3. Now circle groups of 4A. Well, we have 4 A's here. We have 4 A's here. And we have 4 A's here. Okay, so 1, 2, 3 groups of 4A. Every group is going to be represented by an A on the outside. So an A for this group, an A for this group, and an A for this group. And again, we multiply these together. What is A times A times A? A times A times A is A to the 3rd. So we're just going to write this as A to the 3rd. And my question is, what is 12 divided by 4? 12 divided by 4 is what? 3 groups. 12 divided by 4 is what? 3 groups. So we're circling how many groups of 4? 3 groups. You see the division. 12 divided by 4 gives what? 3. Now, same thing with the B's. We're circling groups of what? 4. So we have 4 B's, 4 B's, and 4 B's. Now, before I actually did this, I should have asked, how many times or how many groups of 4 are there in 13? The trick is this. Go to the next number below 13. What's the next number below 13 that's divisible by 4? Hopefully you say 12. Okay, the next number below 13 that's divisible by 4 is 12. 12 divided by 4 gives what? 3. So 1, 2, 3 groups make 12. And how many are left over? You see the extra one left over. We have 1 extra B left over. So each group is going to become a B. So we have a group of 4 B's making a B here, a group of 4 B's making another B, and a group of 4 B's making another B. Since we have 1, 2, 3 groups, we multiply the 3 B's together and we get B to the what? B to the 3rd. Okay? And now we write our fourth root, and whatever is not circled remains. Okay, so notice we did not have a group of 4 3's. We have an extra 3. So put the 3 back underneath the radical. And we have an extra B. Since we circled 12 B's, there's an extra B left over. Put the B underneath the radical, and this is your final answer. So what remains, whatever is not circled remains underneath the radical. Okay, now, we're going to practice the next problem both ways. So I want to see if we can do this without circling. We will circle first, and then we will see if we can do it in our head without circling. Looking at number Well, this example, square root of 32, x to the 8th, y to the 7th, z. Now, we have to start by taking our number 32 and breaking it down. So take 32 and divide by either 2, 3, 5, 7, or 11. What number divides 32? Hopefully you say 2 because 32 is even. 2 times what? 32 divided by 2 is 16, divided by 2 again. 2 times what? 16 is 2 times 8. 8 is 2 times 4, and 4 is what? 2 times 2. How many 2's multiply to give 32? Hopefully you say there's 1, 2, 3, 4, 5. So we're going to write this as the square root of 2 to the 5th, x to the 8th, y to the 7th, and z. Notice we replace 32 with 2 to the 5th because 5 2's multiply to give 32. Now let's go ahead and write it out one more time. We have 5 2's. We have 8 x's. And 7 y's. And 1 z. Okay, now, so we're circling what? We're circling groups of, what is the unwritten number here? The unwritten number here is what? A 2. Recall from the last video, we have what? Square root, we have cubed root, we have fourth root. Okay, here we divide by 4, here we divide by 3, and what is the unwritten number here? It's a 2. So if the number is unwritten, it's a 2. We say the index of a square root, index of square root is a 2, and the number is unwritten. So index of square root is 2. So we are circling groups of 2, or we're circling pairs. Let's go ahead and circle pairs. We have a pair of 2's, a pair of 2's. Now remember, every 2 comes out becomes what? Every 2 comes out becomes 1, 2 on the outside. Every group comes out becomes 1 on the outside. So since we have a pair of 2's, there's going to be 1, 2. We have another pair of 2's, there's going to be another 2. Multiply these together. 2 times 2 gives what? 4. Now we have a pair of x's, a pair of x's, a pair of x's, and a pair of x's. Each pair becomes an x on the outside. So we have what? We have an x for the first pair, an x for the second pair, an x for the third pair, and an x for the fourth pair gives what? 4 x's. Multiply these together, we get what? X to the 4th. Circling pairs of y, 1, 2, 3 pairs. 1, 2, 3 pairs is y, and y giving what? Y to the 3rd. And what's left under the square root? We have an extra, notice something that's not circled, we have an extra 2. And what else do we have? An extra what? An extra y. Now, can we do this? Can we do this without circling or drawing this out in circling pairs? Yes, we can. Let me go ahead and write this up top. Let's see if we can do this in our head. So that we don't want to write this out every time. So looking at the square root of 2 to the 5th, x to the 8th, y to the 7th, and z. Now let's do it in our head. So we're looking at groups of what? Groups of 2. The index 2 is unwritten. This means we're taking out pairs. My question is, how many pairs? We have 5 2's. How many pairs are there in 5? We go to the next number. We're dividing. Remember, we are dividing. Go to the next number below 5. Go to the next number below 5 that's divisible by 2. The next number below 5 that's divisible by 2. Hopefully you say the next number below 5 divisible by 2 is 4. Now my question is, 4 divided by 2, divide. 4 divided by 2 gives what? 2. So you have 2 groups, or you would say how many pairs of 2 are there in 5? How many pairs of 2 are there in 5? Well, there's 2 pairs. So we can say that this is what? 2 squared. The exponent representing the number of groups or the number of pairs. So we take what? We take the next number below 5, which is 4, divide by 2, we get what? The 2 that's circled, the exponent. Okay, remember we're dividing exponents. The next number below 5 is a 4. 4 divided by 2 gives an exponent of 2. 2 squared is what? 2 squared is 4. Now, how many pairs are there in 8x's? How many pairs are there in 8x's? Hopefully you say there's 4. There are 4 pairs in 8. Or notice you can take 8 and divide by what? 8 and divide by the unwritten index 2. 8 divided by 2 gives what? 4, so we get x to the 4th. Now, how many pairs are there in 7y's? Well, if we have 7y's, go to the next number below 7 that's divisible by 2. The next number below 7 divisible by 2 is 6. And 6 divided by 2 gives what? A 3. So we get y to the 3rd. Notice the result after division is the exponent. And how many pairs are there in 1z? There are no pairs. Now, underneath the root, we're left with what? Oh, I forgot. There's a z on the end down here. I forgot the z. Okay, so what do we have here? Well, we took out 2 pairs. We took out 2 pairs of 2. You can see it here. We took out 2 pairs of 2. What was left? 2 pairs was a total of 4 2s that came out. How many 2s are left? There's 1 2 left. We took out a total of 4 pairs of x's. 4 pairs of x's. 4 pairs of x's is a total of 8 x's. Since we took out 8 x's, are there any x's left? No. We took out a total of how many y's? Well, we took out 3 pairs. 3 pairs of y. 3 pairs is a total of 6. So we took out 6 y's, leaving how many y's left over? 1 y left over. We did not take out any z's. There was only 1 z, so we have a z left over. And I made a mistake down here and did not put the z. Okay, so this is our final answer. Hopefully you can see the groups. Last example. And again, I just need you guys to be familiar with this concept. If you're struggling with seeing the groups, we're going to talk about this when you guys get back. But the more familiar that you are with it, the faster we will be able to move. The cubed root of 27, x to the 9th, y to the 12th. Now, let's go ahead and take our 27 and break it down. So 27 is what? 3 times, let's make this a y to the 13th. Or how about y to the 14th? Let's make that y to the 14th. Okay, so 27 is what? 3 times 9, which is what? 3 times 3. So we have a total of how many 3's multiplied to give 27? 3. So we write this as the cubed root of what? 3 to the 3rd, x to the 9th, y to the 14th. And we're taking out groups of what? Groups of 3. Now if I ask you, we have 3 3's. How many groups, if we circle groups of 3, how many groups of 3 can we circle? Well, we can circle 1 group of 3's. My question is, what is 3 divided by 3? 3 divided by 3 gives a 1, so we end up with what? 3 to the 1st power. The 1 represents the number of groups. The exponent represents number of groups. We have 1 group circled. Now, so we end up with 3 to the 1st. We took out all of our 3's. We took out a whole group of 3 3's. So there are no 3's left. Now the question is, how many groups of 3x's are there? How many groups of 3x's? Well, if you have 9 x's, this is the concept of division. What is 9 divided by 3? 9 divided by 3 gives 3, so our new exponent is a 3. We get x to the 3rd. Are there any left over? No, because 9 divided by 3 divides evenly with no remainder. Now, what is the next number below 14 that's divisible by 3? Hopefully you say, next number below 14 divisible by 3 is 12. And 12 divided by 3, 12 divided by 3 is 4, so we get y to the 4th. And how many are left over? Underneath, don't forget your index is a 3. Underneath the cubed root is left what? Do we have any extra 3's? No, we took out a group of 3. We took out 1 group of 3, so there are no 3's left. How many how many x's are left? Well, you took out 3 groups. You took out 3 groups of 3, which is a total of 9 x's that came out, so there are no x's left. Now, how many y's are left? Well, you took out 4 groups. You took out 4 groups of what? 4 groups of 3, which is a total of 12 y's. So 12 y's came out. How many are left? Well, if you took out 12, and there were 14 to begin with, there are 2 y's that are left, and that concludes this lesson. All right, guys.